Welcome to ArXiv Preprint Server Daily, AI Frontiers. In today's episode, we're exploring recent developments at the intersection of computer science and society, with a special focus on how computational technologies both shape and are shaped by our social structures. The papers we'll discuss represent cutting-edge research examining the complex relationship between technological innovations and human societies. These studies address critical questions about the impact of algorithms, artificial intelligence, and computational systems on human behavior, social norms, economic systems, and governance structures. Throughout this episode, we'll identify emerging themes, highlight breakthrough findings, analyze methodological approaches, and delve deeply into some of the most influential papers in this rapidly evolving field. Computer science and society represents a critical research domain in our increasingly digitized world. This field examines the bidirectional relationship between technology and society, how technologies shape our interactions, work, learning, and governance, while social factors influence how technologies are developed, deployed, regulated, and adopted. This dynamic interplay has become increasingly complex as computational systems grow more sophisticated and pervasive. Researchers in this area grapple with questions that span traditional disciplinary boundaries. How can we ensure algorithmic systems treat people fairly? How should we balance the benefits of AI assistance against privacy concerns? What governance frameworks best align technological innovation with public values? These questions require integrated approaches combining technical expertise with insights from law, sociology, psychology, and ethics. The growing prominence of this research reflects a maturing awareness that technological innovations cannot be divorced from their social contexts, especially as AI systems become more deeply integrated into critical decision-making processes affecting individuals and communities. The first major research theme we've identified centers on algorithmic fairness and bias. Researchers are increasingly focused on understanding how computational systems can perpetuate or amplify existing social inequalities, and developing approaches to mitigate these effects. Nguyen and colleagues explore how U.S. courts might scrutinize recidivism risk assessment tools, proposing a framework that integrates legal scrutiny concepts with technical fairness criteria. Their work highlights the gap between technical and legal conceptualizations of fairness, suggesting that technical definitions often fail to capture the nuanced considerations that inform legal judgments about discrimination and equal protection. Similarly, Doss and colleagues investigate social biases in knowledge representations within Wikidata, revealing how these biases create a clear division between Global North and Global South representations. Their findings show that the variance in biased outcomes across geographies mirrors socioeconomic and cultural divisions, potentially perpetuating harmful stereotypes in downstream applications that rely on these knowledge bases. These papers collectively emphasize the importance of considering social context when developing and evaluating algorithmic systems, suggesting that addressing bias requires not just technical solutions, but also engagement with broader questions of power, representation, and justice. Our second research theme revolves around privacy, trust, and AI systems. As AI technologies become more integrated into daily life, researchers are exploring the complex trade-offs between utility, privacy, and user agency. LaRubio and colleagues examine how older adults navigate privacy concerns when using AI assistants for social support, highlighting the tensions between the benefits these systems offer and the privacy risks they pose. Their research reveals that older adults often make conscious trade-offs, accepting certain privacy risks in exchange for the social and practical benefits AI assistants provide. However, these trade-offs are complicated by limited understanding of how data is collected and used, as well as concerns about autonomy and dependency. Esguerra and colleagues approach privacy from a different angle, proposing a novel approach to measuring uncertainty in repeated implicit feedback as a reliability indicator for recommendation systems. By developing Bayesian models to quantify uncertainty in user behavior patterns, they offer a way to balance personalization with privacy, potentially enabling more accurate recommendations while respecting user autonomy. These studies highlight the complex relationship between privacy, trust, and utility in AI systems, suggesting that designing privacy-preserving technologies requires understanding not just technical possibilities, but also how users perceive and navigate privacy concerns in their everyday interactions with technology. The regulation and governance of AI technologies emerges as our third significant theme. As AI systems become more powerful and pervasive, questions about how to govern these technologies have gained urgency. Jennicott provides a detailed analysis of social scoring practices in Europe under the AI Act, examining how the ban on social scoring might impact existing scoring practices. This research reveals the challenges of translating broad regulatory principles into specific technical and organizational practices, highlighting the importance of clear definitions and enforcement mechanisms. Harding and colleagues engage in conceptual engineering around the term AI safety, arguing for a broader, more inclusive definition that encompasses all efforts to prevent or mitigate AI harms rather than focusing exclusively on catastrophic risks from future systems. Their work challenges prevailing narratives in the field and proposes a framework that could lead to more comprehensive approaches to addressing AI risks. Lin and colleagues investigate the challenges in aligning scheduling software with workplace laws, revealing the complexities of regulating algorithmic management in practice. Through interviews with diverse stakeholders, they identify gaps between regulatory intent and implementation, highlighting the importance of considering organizational context and power dynamics in regulatory approaches. These papers collectively emphasize that effective governance of AI technologies requires attention not just to technical specifications, but also to organizational practices, power dynamics, and broader social values, suggesting that governance frameworks should be flexible while remaining grounded in core principles of fairness, transparency, and accountability. Information retrieval and knowledge systems constitute our fourth significant theme. A substantial portion of the papers focus on advancing information retrieval systems to make them more effective, accessible, and responsive to user needs. Ma and colleagues introduced Tevatron 2.0, a unified document retrieval toolkit that works across scale, language, and modality, enabling researchers to explore retriever models with diverse capabilities. Their release of OmniEmbed, described as the first embedding model that unifies text, image document, video, and audio retrieval, provides a valuable baseline for future research in cross-modal information retrieval. Sun and colleagues present SymbioticRAG, a novel framework that reimagines retrieval augmented generation systems by establishing bidirectional learning relationships between humans and machines. By enabling direct human curation of retrieved content and building personalized retrieval models based on captured user interactions, this approach addresses limitations in current RAG systems related to relevance determination and query formulation. She and colleagues propose direct retrieval augmented optimization, DRO, a framework that enables end-to-end training of knowledge selection models and language model generators. These papers highlight the growing importance of retrieval systems that can effectively leverage diverse knowledge sources to enhance AI capabilities, suggesting that future information retrieval systems will increasingly incorporate human feedback and adapt to individual user needs and contexts. Several key findings and breakthroughs stand out across the papers we've reviewed. Sun and colleagues' SymbioticRAG framework represents a significant advancement in retrieval augmented generation systems by establishing a bidirectional learning relationship between humans and machines. This approach addresses critical challenges in current RAG systems through a two-tier solution enabling direct human curation of retrieved content and building personalized retrieval models based on captured user interactions. Ma and colleagues' Tevatron 2.0 toolkit represents a major advancement in unified document retrieval across scale, language, and modality. Their OmniEmbed model is described as the first embedding model that unifies text, image document, video, and audio retrieval, providing a valuable baseline for future research in cross-modal information retrieval. Harding and colleagues' conceptual analysis of AI safety challenges prevailing narratives in the field by arguing for a more inclusive framework that encompasses work on topics like bias, misinformation, and privacy alongside catastrophic risks. Das and colleagues' analysis of social biases in Wikidata knowledge representations reveals how the variance in biased outcomes across geographies mirrors socioeconomic and cultural divisions, creating a clear partition between the global north and global south. Yuan and colleagues' digraph algorithm represents a significant advancement in dynamic spectral graph sparsification, achieving approximately a 10x speedup compared to state-of-the-art algorithms while improving solution quality, with important implications for analyzing large-scale networks in diverse domains. Across these papers, several methodological approaches recur, each with distinct strengths and limitations. Large language model evaluation and adaptation features prominently in multiple studies, with researchers like Xu and colleagues evaluating LLM performance in curricular analytics and Kruff and colleagues exploring contrastive feedback techniques for improving user simulations. The strength of LLM-based methodologies lies in their flexibility and ability to handle diverse text-based tasks with minimal task-specific training. The limitations include potential biases inherited from training data and challenges in ensuring factual accuracy. Retrieval augmented generation (RAG) emerges as another common methodology, with several papers focusing on enhancing RAG systems to improve the integration of external knowledge with language model generation. Longitudinal analysis of digital platforms represents a third significant approach, providing valuable insights into how platforms evolve over time, though challenges include establishing causal relationships and potential selection bias. Multi-stakeholder interview studies feature prominently in several papers, capturing diverse perspectives on technological systems and their impacts. The limitations include potential sampling biases and difficulties generalizing findings beyond specific contexts. Finally, Bayesian modeling of user behavior enables the integration of uncertainty measures as consistency metrics in recommendation tasks, though challenges include computational complexity and difficulties in model interpretation for non-technical stakeholders. Let's take a closer look at our first selected paper. SymbioticRAG, Enhancing Document Intelligence Through Human LLM Collaboration, by Sun and colleagues. This paper introduces a groundbreaking framework that reimagines retrieval augmented generation systems by establishing a bidirectional learning relationship between humans and machines. Traditional RAG systems follow a unidirectional flow where a user submits a query, the system retrieves relevant documents, and a language model generates a response. While this approach improves factuality compared to standalone language models, it fails to capture the dynamic nature of information seeking. Users often struggle to articulate their information needs precisely, especially in domains where they lack expertise. Moreover, relevance judgments are inherently subjective and context-dependent. Sun and colleagues address these limitations through a two-tier solution. Level 1 enables direct human curation of retrieved content through interactive source document exploration, allowing users to refine their understanding and make explicit relevance judgments. Level 2 builds personalized retrieval models based on captured user interactions, creating a feedback loop that improves the system's ability to anticipate user needs over time. The implementation includes a comprehensive document processing pipeline that handles complex documents with rich non-textual elements, an extensible retriever module supporting multiple retrieval strategies, and an interactive interface facilitating user engagement while capturing valuable data for system improvement. Evaluation across 3 scenarios, literature review, geological exploration, and education, demonstrates significant improvements in retrieval relevance and user satisfaction compared to traditional RAG approaches. Our second selected paper is, What is AI Safety? What Do We Want It to Be? By Harding and colleagues. This thought-provoking conceptual analysis challenges prevailing narratives in AI safety and proposes a more inclusive framework for the field. The authors employ the methodology of conceptual engineering to examine what concept of AI safety would be most beneficial for society at large. They begin by identifying what they call the safety conception of AI safety. The idea that a research project falls within the purview of AI safety just in case it aims to prevent or reduce the harms caused by AI systems. This appealingly simple definition seems intuitive. Yet the authors observe that it is in tension with at least 2 trends in how AI safety researchers and organizations conceptualize the field. The first trend is the tendency to characterize the goal of AI safety research in terms of catastrophic risks from future systems, focusing on existential threats potentially posed by advanced AI systems. The second trend is the increasingly popular idea that AI safety can be thought of as a branch of safety engineering. While acknowledging the importance of addressing such risks and bringing engineering rigor to the field, the authors argue that these narrow focuses artificially separate work on catastrophic risks from work on near-term, concerns like bias, privacy violations, and misinformation. The authors make a compelling case for adopting the safety conception as the preferred conceptualization of AI safety, allowing us to see continuity between work on topics that have historically been treated as central to AI safety and work on topics that have been treated as more marginal. Our third selected paper is Regulating Algorithmic Management, a multi-stakeholder study of challenges in aligning software and the law for workplace scheduling, by Lin and colleagues. This comprehensive examination makes a significant contribution by moving beyond technical compliance to explore the entire process of regulating algorithmic management, including rule operationalization, software use, and enforcement. The authors conducted interviews with a diverse set of stakeholders involved in enforcing or complying with workplace scheduling laws, including regulators, advocates, defense attorneys, scheduling managers, and workers. This multi-stakeholder approach reveals the complex interplay of technical, organizational, and legal factors that shape how scheduling software affects compliance with workplace regulations. A key insight from the study is that the process of regulating algorithmic management cannot be reduced to simply aligning software with legal requirements. At the rule operationalization stage, there is often ambiguity in translating legal language into computational logic, with different stakeholders interpreting requirements differently. At the software use stage, scheduling managers often develop workarounds when software constraints conflict with operational needs, potentially undermining regulatory intent. At the enforcement stage, regulators face significant challenges in monitoring compliance and gathering evidence of violations. The authors propose several recommendations for addressing these challenges, including explicit requirements for software transparency and auditability, collaborative approaches to rule operationalization, and consideration of the organizational context in which scheduling software operates. Looking to the future of research at the intersection of computer science and society, several promising directions emerge. First, there is growing interest in collaborative approaches to AI development that actively involve diverse stakeholders, including those most affected by AI systems. The human-on-the-loop validation interface described by Sun and colleagues and the multi-stakeholder approach advocated by Lin and colleagues exemplify this trend, which has the potential to produce more inclusive and equitable AI systems. Second, there is increasing recognition of the need for interdisciplinary approaches that bridge technical, legal, and social perspectives. The framework proposed by Nguyen and colleagues for integrating legal scrutiny concepts with technical fairness criteria exemplifies this trend, as does the conceptual analysis of AI safety by Harding and colleagues. Third, there is growing interest in developing AI systems that can adapt to individual needs and preferences while respecting privacy and autonomy. The personalized retrieval models described by Sun and colleagues and the uncertainty measures proposed by Esguerra and colleagues represent steps in this direction. Finally, there is increasing attention to the global implications of AI technologies, with researchers examining how these technologies might bridge or exacerbate existing divides. Several key challenges remain, including developing governance frameworks that can effectively regulate rapidly evolving AI technologies, addressing global inequities in AI development and deployment, and finding ways to balance the benefits of personalization with respect for privacy and autonomy. In conclusion, the papers we've examined today reflect a field in transition, grappling with the complex challenges of developing AI systems that are technically robust, socially beneficial, and ethically sound. Sun and colleagues demonstrate the power of bidirectional human-AI collaboration in information retrieval, creating systems that learn from and adapt to user needs. Harding and colleagues highlight the need for inclusive frameworks addressing the full spectrum of AI harms, breaking down artificial distinctions between different types of AI safety concerns. Lin and colleagues reveal the importance of multi-stakeholder approaches to AI governance, showing how technical compliance alone does not ensure just outcomes. By bridging technical innovation with careful consideration of social implications, researchers are laying the groundwork for AI systems that enhance human capabilities while respecting human values and rights. The increasing focus on interdisciplinary approaches, stakeholder involvement, and global equity represents a positive trend, suggesting growing recognition of the importance of considering diverse perspectives in AI development. As we move forward, maintaining this integrated perspective across disciplines will be essential for ensuring that AI technologies align with human values and promote equitable outcomes. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from ArXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.